How it will look. You will see the organs here. You see the kidney here.
Yeah.
Sorry, you see the liver here.
Yeah.
And this is the spines.
Yeah.
These are the vertebra.
Okay.
Right. So this is an actual tissue mimicking phantom. You get the exact feel. If you put a needle through this, you will feel as if you are pushing it through the lung or the abdomen. And so we'll use this to demonstrate how the equipment would work.
Mm-hmm.
How it will look. You will see the organs here. You see the kidney here.
Yeah.
Sorry, you see the liver here.
Yeah.
And this is the spines.
Yeah.
These are the vertebra.
Okay.
Right, so this is an actual tissue mimicking phantom. You get the exact feel. If you put a needle through this, you will feel as if you are pushing it through the lung or the abdomen. And so we'll use this to demonstrate how the equipment would work.
Mm-hmm.
So this is, assume this is the cross section of the human body.
Mm-hmm.
And the doctor, pick a target.
Yeah, of course.
The doctor, so let us for this demonstration, assume this is a tumor. This black surface here is a tumor, and he wants to actually put a needle to the tumor, take out a small piece of the tissue, and then study whether it is cancerous or not. We're going to be demonstrating how that works here. So the doctor, using this red circle, he has marked saying that I need to get to this point. And he picks a point on the skin surface, which is called the entry point, depending on which is the best path that he can identify. If there is a blood vessel here, he wouldn't choose this. Probably he would choose something like this. So you can get an angulation. It's not just straight insertion, you can get an angulation. So he can choose the path depending on whether there is a critical organ in the path, or if there is a bony structure, or if there is anything else that he should not be puncturing, he can avoid those and plan. We allow them to plan. The doctor can actually do the planning here. Typically today, this planning is done in the mind. Right?
Mm-hmm.
So he knows, okay, I'm going to be accessing the tumor, knowing fully well that there are a couple of critical organs, so I should not puncture them. It's all in his mind. He doesn't get that right. Right? So he does. So currently we allow the doctor to do the planning here. Once the plan is confirmed, automatically it will convert this plan into a length of the needle that he needs to use, so that he can put the needle through there and reach the tumor here. So that needle calculation is done here.
Where does the robotics play into it?
Okay, we'll demonstrate the robotics play here.
So we enter the needle.
Yeah. So the needle length is calculated, and if you have a needle length more than what is required, we key in that needle length and we say calculate. Now the system has converted this point, which is a target point, and this point, which is an entry point, into a set of coordinates that the robotic system needs to achieve. Right? And so it also shows right now, for this plan, will the robot touch the patient or it will stay away from the patient? You cannot have the equipment touch the patient, right? It should stay minimum. So as long as this does not touch the surface, you are having a safe plan. Okay, so let us say we confirm that this plan is all right.
Send back.
Yeah, so you confirm by sending the coordinates to the system.
So
Now machine is ready for operations. So the coordinates have all been sent here.
So you proceed. So what happens? This angulation is already given by the machine. So what doctor needs to just insert the needle through this end effector. So all the calculation is done by the machine, the robot. So doctor has to just manually insert. Okay. You can just insert the bush. You can just tell about the bush also.
Yeah. So this is a sterile bush. This accommodates various types of needle lengths and needle gauges.
All standard.
So yeah, these are commercially available needles. So they come in different heights, different lengths rather, and different thicknesses. So depending on the type of the needle, we provide a sterile bush, which is thrown away after use, after every procedure. So we put that here so that So using this now, I can put the needle through the bush, and I'm the doctor. I don't need to worry about the entry point, which is this point here. I don't need to worry about it. And I don't need to worry about the angle with which I need to push the needle. And I don't need to worry about when I need to stop. All the three are taken care here. All that I need to do is just push the needle fully. That's it. At this point of time, the entry point, as you see here, correlates with the entry point that you marked. the angle, because you see this is a slant one, that correlates with the angle here. And where the needle has reached already would correlate with the target point here.
So this is done by robotics then?
Yeah, the
I
movement
see.
coordination
The movement
is
of the
yeah.
equipment.
So the positioning, the trajectory enforcement is enforced through the robotics. The final insertion of the needle, we have consciously left it to the doctor. Because you saw me push, at that time I could feel that the needle was going through the kind of tissue that I wanted. By mistake, if the doctor had planned wrongly, and if there is a bone, the doctor would feel that he is pressing a bone. He would stop the procedure and press the emergency key and go and replan. Or if he was going through a cartilage or a blood vessel, the doctor gets the feel. That's called the tactile feedback. That we have ensured that is kept available for the doctor. Typically, if you have the robotics driving the needle, the doctor would not get the feel. So let's say you have an uncooperative patient. He gets worried, excited, anxious, and he wakes up and gets up from the table. And if you have the robotic driver pushing the needle, you have a very clinically complicated condition. So to ensure unsafe condition. So to ensure that the procedure is safe, we allowed the doctor to manage the final insertion.